The results of the intermediate value theorem are something that we live with every day in the so-called real world or in the world around us. Especially when we travel, we know that we have to travel from one place to another and pass through a whole bunch of points in between. We don't have the ability to teleport yet, or to instantly pop through wormholes, or do things like that. We have to actually travel in a continuous manner from one place to another. So since the fact of our travel, regardless of speed, ends up being continuous, our travel is governed by the intermediate value theorem. So on the left here, what we have is a picture of a hill. And let's say that someone wants to walk up that hill. They're out hiking. All right? They're going to pass through every possible height above ground level as they progress from A to B. So if we pick any specific value of height in between the heights of A and B, there will be at some point during this person's walk that they will actually have that height. So there has to be some kind of a correspondence between heights and time. It's impossible for the person to be at a height somewhere between A and B and not have that correspond to some time between when they started at A and when they ended at B. That would involve, again, teleportation or something like that, something that we're not capable of doing. We can extend this, actually, and you'll have a WebAssign problem that talks about this idea, and say that not only is that true, but if that person, after they've gotten up to B, then turns around and walks down, then for both trips, there will be a height. And the time that the person is at that height will be exactly the same for both in the up and the down. And we can do that, and you'll be asked to do this in your problem, by first kind of considering a simple linear function for how somebody walks up a hill, then coming up with a second linear function for how they walk down the hill. In both cases, we start the time at 0. So for up, 0 is at A. For down, 0 is at B. And then we'll take the difference between those two functions. We'll subtract one of the functions from the other function. So what we'll really end up saying there is if the person's at the same height at the same time on both days, then the difference between the two functions will be 0. And that's what you're looking for. You're trying to see if you can find the value, the time, for the value of 0 for the difference between those two functions. Again, you'll have a chance to try that in WebAssign. Another example is with plane flight. So assume that the second graph on the right-hand side here represents a plane that takes off from some city. It gets up to some maximum height and eventually comes back down and lands again. If we define the middle point here as kind of the maximum height, and then pick some height in between the maximum height, well, then we can apply the intermediate value theorem on the left-hand side to show that there's some point in the flight where the plane takes on that height in between, or altitude in between landing and its maximum height. And if we apply the intermediate value on the other side, the second half of the flight after the max, we can do exactly the same thing. So we can show that the plane takes on some altitude in between its minimum and maximum altitudes at least twice during its flight. Now, if it does go up and down because of weather or other things, it may take on that altitude more than twice. But it has to take it on at least twice. And we can show that and prove that using the intermediate value theorem. So there's a couple of examples of how we see the intermediate value theorem in the world around us. You might want to try and see if you can think of some others.